Welcome to this video on vaccination. We'll cover how vaccines work, their importance in immunology, and key concepts for your GCSE Biology exams. In this video, we'll break down the science of how vaccines safely trigger an immune response, the role of memory cells, the concept of herd immunity, and the safety benefits of vaccination. What is a vaccine? It's a biological preparation that provides immunity against specific infectious diseases by introducing a safe version of a pathogen, allowing the immune system to prepare without causing illness. Vaccines use various pathogen-derived materials to trigger an immune response, such as weakened pathogens, inactive pathogens, or specific pathogen antigens. Antigens are proteins on the surface of pathogens that act like identity badges. When the immune system detects an unrecognized antigen, it launches a defense response, a mechanism vaccines exploit. When vaccine antigens enter the body, they are detected as foreign, triggering a primary immune response, where the body's natural defense system acts to neutralize the perceived threat. The immune response is a four-step process: vaccine antigen introduction, antigen detection, antibody production, and finally, memory cell formation. White blood cells are our primary defenders. Phagocytes engulf and destroy pathogens, while lymphocytes produce antibodies to neutralize specific antigens and create long-lasting immunity. Lymphocytes produce specific antibodies that bind to antigens like a lock and key. This binding neutralizes pathogens or flags them for destruction by other immune cells. Remember this key exam point. Antibodies are specific to one type of antigen. A vaccine for one disease will not protect you from another because the antibodies are different. Memory cells are the real power of vaccines. These long-lived cells remain in the body after an initial response, providing the foundation for lasting protection. The process begins with vaccination, leading to a primary response and the formation of memory cells. These cells ensure that future exposure triggers a rapid response. The primary response to a first exposure is slow, taking days or weeks. However, the secondary response, driven by memory cells, is much faster and stronger. Because memory cells allow for a rapid response, pathogens are often destroyed before symptoms can even develop, effectively preventing illness. In conclusion, memory cells provide long-term immunity, making vaccination an essential tool for public health and individual protection. When one person is vaccinated, they gain protection. But when large numbers in a population are vaccinated, it becomes difficult for a disease to spread, as infected individuals are less likely to encounter a susceptible host. This concept is known as herd immunity, or community immunity. It occurs when a sufficiently high proportion of the population is immune to a disease, making widespread outbreaks unlikely. Herd immunity is vital because some individuals, such as newborn infants, the elderly, or those who are immunocompromised, cannot be vaccinated. They rely on the indirect protection provided by an immune community. The herd immunity threshold varies by disease. More contagious illnesses, like measles, require very high vaccination coverage, around 95%, compared to polio or COVID-19, which have different requirements. Vaccination has truly transformed public health, dramatically reducing or even eliminating diseases that once claimed millions of lives each year. Significant successes include the total eradication of smallpox, the near elimination of polio, and the drastic reduction of measles cases worldwide due to persistent global vaccination efforts. Vaccines undergo a rigorous, multi-stage testing process before approval. This ensures they are both safe and effective for public use, often taking years of careful research and trial monitoring. Clinical trials proceed in 4 key phases, from initial laboratory safety tests in Phase 1 to dosage and immune response studies, large-scale effectiveness trials, and finally, ongoing post-approval monitoring. Common vaccine side effects like soreness or mild fever are temporary signs that your immune system is responding. Serious adverse reactions are extremely rare and are strictly monitored by health authorities. A central medical principle is that treatments are used when benefits outweigh risks. For vaccines, the risk of harm from preventable diseases is significantly higher than any potential side effect. To summarize, vaccination avoids the severe risks of illness, hospitalization, and potential disability that come with infection, while providing safe, long-term protection. By maintaining high vaccination rates, we protect the most vulnerable in our society who cannot be vaccinated themselves. It is a shared responsibility that fosters a safer community for everyone. Before your exam, remember these essential terms. Pathogens cause disease. Antigens trigger the immune response. Antibodies neutralize the threat. And memory cells ensure long-term immunity. This flow diagram represents the full vaccination process. Be prepared to describe these stages clearly and accurately during your examination. Finally, both natural and vaccine-induced immunity produce the same long-term protection through memory cells. Vaccines simply provide a much safer path to that same vital outcome. Modern medicine uses various vaccine types to introduce antigens. We'll explore live attenuated vaccines, which use weakened pathogens, inactivated vaccines, subunit proteins, and newer mRNA technology. For some diseases, immunity wanes over time. Booster doses are given to top up immunity by re-stimulating existing memory cells, ensuring a strong, rapid secondary response. Countries utilize a national vaccination schedule to provide immunity at specific developmental stages. In the UK, this begins at birth and continues into adulthood to ensure long-term coverage. Maintaining high vaccination rates is critical. When coverage drops below the herd immunity threshold, outbreaks can return, making every vaccinated person a vital part of community protection. Exam questions often focus on explaining how vaccines protect you, how herd immunity functions, and evaluating the overall benefits of vaccination compared to the risks. For top marks in your exam, always mention memory cells for long-term immunity. Emphasize that antibodies are, quote, specific to antigens, and describe the secondary response as faster and stronger. Here is a vocabulary checklist for your revision. Ensure you can define terms like pathogen, antigen, antibody, lymphocyte, memory cell, and herd immunity to build a strong foundation. Let's test your knowledge. Try to answer these 4 questions on vaccine contents: the speed of immune responses, the importance of herd immunity, and the balance of risks and benefits. Review your answers here. Vaccines provide antigens. Memory cells create faster secondary responses. Herd immunity protects vulnerable people. And vaccine benefits significantly outweigh the risks. You've mastered the essentials of vaccination. Remember, linking protection to memory cells is your key to success in the exam. Good luck with your studies.